Hey guys, quite a number of us are used to using the DEX DApp to swap coins when we need to. But a few days ago, a number of people were asking me if um, I could show a way to use a DEX smart contract to do a swap of some tokens from inside my smart contract. And that's what I'm going to show today. Using the UI, the DEX DApp is not the only way you can swap your tokens. Since the smart contracts are deployed online, then you could as well call some of those smart contracts and get them to swap some of your tokens for you. And you can use this for different things. You can use this for e-commerce, for example, where you could accept your tokens from the user in one currency, in one token, and then automatically swap it to the real currency that you want. So for example, let's say you have an e-commerce store and you prefer to accept USDT, and then but you want to allow people to pay you in USDC, in DAI, in ETH, in whatever. So what you could just do, you could use Uniswap, use the V2 contract, call it from your contract to swap the coins once they are paid into USDT and deposit it into your own wallet. So that's what we're going to be doing. Of course, you can see here, you can easily have used the interface. For example, I want to swap the USDT to the Matic token, and you can see the rate here. Of course, I don't have enough balance to do that, but of course, if you had balance, you will have been able to do that. Now I'm going to show how we can do this same thing via a smart contract. All right, let's go. Okay, so the first thing we're going to do, of course, is set up add ads. I hope you already know how to do that. If not, look, I think I have a tutorial that does that. Now, this other tutorial I also talks about how you can fork the mainnet of any of these networks and use them locally. So please make sure that you're on ADAT version 2.7 and above, because the only ADAT 2.7 and above supports the London hard fork, the EIP 1559, that allows some features. All right, so once you do that, have a look at my mainnet forking tutorial, and you'll see how to fork the mainnet. I'm forking the mainnet using Alchemy, so, and then I'm using this block number, right? So on this block number, and so configure your ADAT to do this, and then we can go ahead. All right. All right, so once you've done that, the next thing you can do is to run ADAT, the ADAT node, locally. So just run that MPX ADAT node, and okay, so that's our node running, so we can connect to it locally. All right. So now we have a ADAT setup. We have it on the mainnet at this block number, and then now we can look at what we actually want to do. So we're going to write two contracts. One, actually, the swapper contract, but we need a way to actually interface with the smart contracts. That's Uniswap or any other router that follows the Uniswap router format takes, and that's why we have this interface. And if you look at this interface, this is an interface that is extracted from the Uniswap router v2, and as you can see here, it allows you to swap ETH for tokens, tokens for tokens, tokens for ETH, and etc. So we didn't have to write this code because it already exists, so we're just going to import this into our swapper contract. Then we need to go ahead to import the console, the ADAT console. That's just for debugging. So we import the DEX router, and then I have another import here, the safe ERC20, which is just a helper method from OpenZeppelin to allow us to transact with ERC20 a little better. So and that's what this line is doing. All right, so we've written a swapper contract in such a way that it can work with any router that implements this interface. Remember, there are quite a number of DEXes that actually use the router v2 that was implemented, or at least invented by Uniswap. So you could use this same code with Uniswap, their v2, Sushiswap, Pancakeswap, Bakery Swap, and the list is quite endless, right? So for us to be able to switch out the routers easily, we pass in the router address via this constructor, and then yes, sometimes we might need the wrapped ether on any of those routers, so we also pass that in, right? And then we're saving the instance of that into this. All right, so that's clear. Now to the real meat of what we're going to be doing. We're going to be writing a swap method that takes in two tokens. The first token will be the token that we want to swap for the token that we need. So you're swapping token in for token out, and then the amount that we want to swap in, and then the minimum amount that we want to swap out. Now remember that your DEX works is a decentralized exchange. No one determines the actual exchange rate. It's determined by the formula, right? So minimum amount in just is a way for you to specify the minimum amount of token out that you are willing to get. And then of course the receiver is who this amount is going to be transferred to, the amount that is swapped. So the minimum amount is not necessarily the amount that we swapped. It could be higher than that, and it could be equal to that. Everything will be sent to the receiver. So we have a swap function which we will now be able to call. So we have a swap function defined, so let's go ahead to implement it. We're going to have to save in the sender. That's the caller of this function. Now we will need to transfer in the amount of token in that we want to swap to this contract, and what we need to check before we do that, we need to check that this contract has an allowance to be able to spend the amount that we want to swap on behalf of the sender. So we're going to check the allowance. Oh, okay. Sorry about that. So we're checking for this sender for this contract. Right. Now all we just need to do is check if that allowance is greater than or equal to amount in. If it is, we go on. So say swapper. Okay. Now once we can confirm that the allowance is greater than amount in, then we can just transfer it in. Now to transfer in, we use a function called transfer from. So we're going to transfer from. Okay, so we're going to transfer from the sender to this contract, and the amount that we're transferring in is amount in. Okay, now transfer from is the default ERC20 function for transferring on behalf of a user to another user, but it is implemented in different ways by different contracts. So some contracts have a return value, some don't have a return value, and all that. So sometimes that can leave your contract in an unstable state where it actually is not sure if it was actually transferred. So we'll switch that to use safe transfer from Open Zeppelin. All right. So safe transfer from. Yes. Now the next thing we're going to do is also give this contract, excuse me, we're going to give the router contract So the next thing we're going to do is give the router contract approval to spend on behalf of this contract. So we go again. Okay, and just as we did here, we're going to use safe approve. But then safe approve has been proven by OpenZeppelin is actually depreciated by OpenZeppelin. So instead of safe approve, what we're going to use is another function called safe increase allowance. So the router now has the ability to trade on behalf of this contract. Okay, so we're good. We've transferred in the coins that we want to swap. We've given the router approval to spend on behalf of this contract. The next thing that we need to do is to actually call the router contract to do the swap on our behalf. And for that, we are going to have to define the tokens, the path that of the tokens I want to transfer or that we want to swap. So I'll define an array here to represent the path. Okay, so the path is the path that the router is going to use to swap your token to the destination token, right? And it allows you to specify intermediate tokens. So sometimes you want to swap maybe USDT to BNB or to another coin, and then you find out that it's sometimes more cost effective to transfer from USDT, for example, to wrapped ETH first, and then transfer and then swap from wrapped ETH down to BNB. So if you want to do that, you could just do a path of 3, and then path 0 will be token in, then the next path, okay, so made a mistake there. So we're going from token in to token out, but we want an intermediate token first. So remember, we have our wet address here. So I'm going to change this to this. So it's going to go from token in to wet, then to token out. You could as well just go from token in to token out. And if you're going to do that, we could do this. All right, good. So we have almost everything that we need to call the Uniswap router now. One other thing that we need is the deadline. And the deadline is useful when, for example, you are calling this contract from another contract or from a DApp, and because things can change very fast, so you are specifying the deadline after which this swap is no longer necessary. So you could also just use block the timestamp, or then you could decide to add maybe, I don't know, depending on whatever you like, but I'm just going to stick with block the timestamp. All right, so we're good. So the last thing that we now need is to actually call the router itself to actually do the swap now. And for that, we're going to call the router as defined here. Yeah, router dot swap token, swap exact tokens for token. Then we're going to specify here the amount in, the amount out, minimum amount out, right? Then the path, the receiver, and then the deadline. Okay, so that's our contract, that's our swap function. Whenever we call this now, it's public here, or external. Okay, since we're using this, it's fine anyway. So yes, that's our contract. Now, of course, we need to test our contract, so we're going to look at our test. We're going to write a test. Okay, so that's it. So now we just need to move on to the testing function. Okay, now to our test. So a few things that we need to set up: import all this. Now we use type chain, so we could import the swapper factory and swapper from type chain, and of course just do a few other setups. We need the add at runtime to be able to impersonate an account, and then we need an ERC20 ABI. We just put a few methods that we need. All right, now you need the router address, and then the address of the tokens that we're interested in. In this case, we want to swap USDT for Matic, so we have the addresses set up. We actually don't use USDC. Then and before each, we deploy the contracts that we need. Of course, if some of these things are strange to you, just look around for a tutorial on ADAT tests. But in before each, what we do here, we get the swapper factory and we use it to deploy our swapper contract. And of course, we have to specify the router address and then the wrapped ETH address. So we put in our router and the wrapped ETH, which we already have from here. So now to our real test. All these are set up. This is the test. The first thing we just check is to make sure that the swapper actually deployed correctly. Okay, now once we have that, the first thing we are going to do is to get an account to impersonate that has enough USDT that we can use to swap. And that has enough ETH to be able to use to pay the gas fees. And so I looked around and I found an account. So I'll call that account to impersonate. And how did I get that? All I had to do was just go to Etherscan, look for the tokens, look for USDT, and then I looked for the holders of USDT, the top few holders, and I just selected one, this. So as you can see from here, this is his address. This person has enough ETH balance to pay for gas, and I also checked he has enough USDT that I can use to swap, even as Matic, but we don't need that right now. We're swapping into Matic. So all I did was copy the address, and then that's the account that we'll be using. That allows you to impersonate anyone on the mainnet once you can fork the network. So once I have the account, then I have to actually make a request to Hadat to impersonate that account. So I do this by running the right, and the method I'm calling is add at impersonate account. I get that spelled right? I think so. And what am I impersonating? Okay, so I wait for that to complete, then I look for all the sign-ins. Okay, and I get the accounts from that. Okay, so we're good. So now I can then look for my USDT contracts that is connected to that signer. Passing the ABI and then passing the signer. Okay, I'm good. All right. Okay, so what did we do here? We called her that and asked for permission to impersonate this account, and then we got a signer that is attached to that account that will allow us to sign different transactions. So what we do here is now get the USDT contract, and then also now get the Matic contract so that we can get their balance, the balance for that user, right? So Matic, remember they are both ERC20, so we can use the same ABI, right? Then all we now need to check is get their balance, and for that we just call the contracts USDT contract dot balance of. Do the same for Matic. So we're going to use the format units. Remember, balances are represented in big number, so we need to format that to something human readable. And USDT actually has 6 decimals, unlike Matic that has 18. So change this to 18, change this to Matic. Okay, so we're about ready to call our contract, the swapper. But remember, before you can actually swap, let's define how much we want to swap, right? We use both format units and pass units to convert from and to big number as needed. So USDT has 6 decimals. All right, so we are swapping. Let's put that out. We're swapping how much? Okay, well, actually I don't need that. So that's how much we're swapping. Now to call the contract, remember you are transferring the tokens into this contract, and it means that the allowance has to be greater than this. So you need to call approve first of all. So let's say sorry. So you're approving it for the swapper address, right? And then of course, how much are you approving? You're approving, let's approve something a little higher than what we need. So yeah, 6 digits. Okay, then we need to actually wait for that to be mined. Okay, so now, yes, we have our contract approved to spend on our behalf. Then we can now call our swap. Swap. But remember, in Hadat, if you call a contract instance without specifying the signer automatically uses the first address in our account, in the ADAT account. So we want this to run from with the signer instead. So we're going to connect it to the signer, and then only then can we now call swap, right? Okay, so the first thing we're doing is specifying the token in, and then the token that we want out, then the amount to swap, right? Then the minimum amount that we want out. Not sure of the rate right now, but I mean, you can do all the calculations to get the rate later, but this is just to show that the swap works. And then once we do that, okay, so the token in, token out, the amount to swap, minimum amount, and then what's the last thing? Receiver. Okay, so receiver, yeah. So for receiver, we want it to be the same account, which will be this. So okay, so wait for that to be mined. Now after that is mined, we need to check the balances again. So we just use this. Okay, and really to complete the text, you need to assert that the balances are different and all, but I'll leave that as an exercise for you, but I'll just log that out. Okay, so let's try and run our test. Remember, we have a node running here, so to run our test, we just do add that test network. Okay, we have an error somewhere, 64 and 64. Okay, so made a mistake with that. That should be ethers. So change that. Okay, great. So our swap contract works. As you can see, here's the balance before, here's the balance after. Our USDT has been changed, so this decreased and then this increased. So this should actually be after. But you get a gist. So that's it. That's great. So that's how you write the swap. You just need to look at the router interface, and you can do the same thing: tokens for tokens, tokens for exact tokens, ETH for tokens, tokens for ETH, and we have a few other functions here. Use the same functions for ETH supporting fee on transfer tokens. Now the difference is that you can call these other methods, these methods ending with supporting fee on transfer tokens, with RFI type tokens, so tokens that charge a fee on transfers and all. Yeah, you can use that supporting fee on transfer tokens for those type of tokens. Okay, great. Thank you. Remember, subscribe, share, like. See you in the next video.